All right, so what we're going to do today is we're going to look at another type of system. Okay, I think you guys realize that we're in the systems chapter, but uh, there's another type of system. It's a system of inequalities. Now, this would be something that you've seen before, but as I've said with a lot of things in this chapter, we want to make sure that you're good at them, that it becomes something that you're as confident with as you are with other math, um, and so let's use this little half sheet of paper. I figured it was a little easier to have a spot for you to take a couple notes. And then just so you know, the back of it is like a mini assignment, which the goal is that you're going to get to look at that today because usually you do a better job on stuff in class. So, but don't worry about the back yet. Let's spend a few minutes on the front. Most kids need a brush up. And let me remind you of two things about a system of inequalities. First of all, when the answer to it is not just a point. It's not like it's one point, but rather it's a whole shaded region. So we often call that the common shaded region. But you have to understand that when you do some shading today, you're actually shading the answer. Okay? Which really means there's a lot of answers because it's all the points that are inside the shaded region. Now, the corner points will end up being the most important points. They will be by the time we kind of finish the lesson and next week also. So just trust me, the corner points are very important. And we want to understand that they have to meet these two criteria: intersection of lines and also touch the shaded region. And it's going to be easier if we just talk about that as we do the two problems. But I'm just telling you, these corner points are actually the most important points. All right. Now, I know this isn't your first rodeo with these. Maybe you had a teacher that, you got out the colored pencils, and, if that kind of thing motivates you, that is fine. I actually have colored pencils back there. Or if you're kind of like, I'm good, I'll just shade it in with my pencil, that's fine. But we're talking about trying to shade both of these equations so that we can come up with the common region. Okay, and some of this is just, do you know how to graph a line? Okay, and make sure that you do, because when I look at negative 3x plus 6, I see y equals mx plus b. I'm sure you do also, so I hope that it's the 6 that grabs your attention as a nice little starting value. It's just a sketch, but, get somewhere around 6, and maybe note that you're labeling, that you're plotting that point. Now, the slope is negative 3. The slope is negative 3. Again, it's just a sketch, but I want to go down 3 and over 1. I want to go down 3 and over 1. I can kind of do that a couple times and get a sense of the direction of this line. Now, before you draw that line, did you already draw it? Remember, if it's just greater than versus greater than or equal to, remember, you have to have a dashed line. That dashed line signifies that you're not equal to it. So that's one of those things that before you draw the line, just take a look. Now, the answer to this problem, at least so far, is the region that's greater than this line. Now, because this equation is solved for y equals, I can just look at this line and say, geez, the greater side would have to be the side that's on the top. Again, I can just look at the line and say greater would be the top side. But there's also this method that you probably remember, but let me refresh. It's called a test point, where I plug in a point, usually 0, 0, if it's not on the line, but I test the point 0, 0 to see if it comes out true or false. And it's not bad just to think about that for this problem. If I test the number 0, I get the statement that 0 is greater than 6. Well, how does that sit with you guys, 0 greater than 6? It shouldn't sit very well. You should say false. Now, false just means that this test point down here is not in the shaded region, which is why we're shading on the other side. Okay, so we're good so far, but we have a second inequality. That second inequality is going to make another boundary. Okay, now remember how to graph the boundary. Y is less than 9. You might want to think of it temporarily as y equals 9, if that helps you to think of it as a horizontal line. As a horizontal line. It's a horizontal line that's going to intersect up here at 9. So again, it's just a sketch, but you can kind of find the position of 9 and draw your horizontal line. You made it dashed, right? Most of the time, people just look at the less than sign and say less than the line, which is completely fine. Less than the line would be obviously on the bottom side. The bottom side. Now remember, what we really seek here is the shaded region, I should say the common shaded region. The common shaded region is where both arrows are intersecting. And this is where you either get out the side of your pencil or a colored pencil. Don't make a mess, okay? If you have shading everywhere, somehow this shaded region has to stand out. It has to be darker, or maybe as I've done, it's the only shaded region.
Cover the arrows.
You can cover the arrows, yes. Of course, some of the arrows don't get covered, the ones that were not in both regions. I'm actually going to erase those arrows lightly, again, just so I don't have a mess. Okay, now remember, all the points in here, all the points, this one, this one, this one, this one, all the points are solutions to both of these inequalities. Okay, but there's one point that ends up being kind of the most important point. It's the corner point. For this problem, there's only one corner point, but there's something special about it. It's kind of on like the edge of the answer. More on that on Monday. Check that on Tuesday. But let's find this corner point. It's actually something that's part of the solution today. Warning, warning, this is like the mathematical part of the problem. Okay, how do you find the intersection of two lines? How do you find the intersection of two lines? That's what this chapter's kind of been built on. That means solving this system. Kind of like solving this system as if it was two equal signs. Now, I know I'm kind of just making those equal signs mentally so that you guys are comfortable saying, okay, I'm going to substitute 9. I'm going to like do the substitution method. I'm going to solve like it's a little system. And notice that when you do that, it's like you're solving for x. Ah, perfect. You know, we're solving for a point. Again, can I just kind of pretend this is an equal sign? Yes, because I'm finding a point that's equal. Okay, it's okay. Don't get confused with the greater than, less than signs when you're solving for a corner point. Of course, x equals -1 with some basic algebra. Now, I already know that y equals 9, so I think I have my point. I have my point, 1, 9. And again, that is going to end up being the most important point when we come back next week. So what you do is you find it, and usually you put it in like a little table or a little box to make it stand out. Let's do one more. Let's do one more. You're probably going to want to kind of do it with me. But of course, if there's some things that you feel like you understand, feel free to think about it before I do. It is a little different. The form of the equations is a little different. The process is still the same, trying to come up with each shaded region. X greater than 0. Sometimes zeros, especially when it's just like X or Y, get us kind of like befuddled. But X equals 0. Remember, you can always think that way to get your line. That's just the y-axis. Okay, X equals 0 is the y-axis. So if I want to be greater than, then I'm really just looking at positive X numbers. Don't make a mess, but realize that right now we're to the right of the y-axis. Y greater than or equal to x squared. I hope you notice it's got an x squared, but I hope it doesn't make you panic. Okay, a student like you should know that x squared is a parabola. Kind of messed around with it a little bit a couple chapters ago. We're going to mess around with it more in the next chapter. But it's a parabola, and it's a parabola that has a vertex. The vertex is sort of at its original starting point, double zero. Okay, the reason we know that is because there's no numbers that are shifted that have made it shift. So what I'm basically saying is all we really know is this, but it's enough. That's all we need to know, that we have a parabola that is at 0, 0. Okay, people say, so I don't need any other points? I don't think so. I think if you can draw a parabola that touches 0, 0, you're fine. Now, it is greater than the parabola. Okay, interesting. It is greater than the parabola. You can either look at this graph and you can say, where's the top side? Now, the top side would be the side that goes above the parabola, which, using the arrows, would be on the inside for this problem. I don't want you to think the inside is always the top side. It depends on which way the parabola is faced. But it does say greater, and I can just say that I'm above the parabola. I'm going to do that instead of using a test point because it's a little easier. Let's talk about this equation. Love for you guys as students that have been through multiple math classes to make easy work of this equation. And one of the easiest ways to graph this equation is just to use x and y intercepts. Listen, x and y intercepts is an easy way because all you got to do is plug a 0 in for y. Now, I'm showing this, but really, this is something you can do mentally and easily say that x equals 3. X equals 3 is the x-intercept, and it was easy to find. It's the same thing with the y-intercept. All you got to do is plug a 0 in for x. Again, maybe you can just do this mentally. Okay, because, well, you basically get 0 plus y equals 12, which means y equals 12. X and y intercepts, when an equation is in this form, usually you just want to plug in zeros. Now, if you were like, can I solve this for y equals mx plus b? You can. Okay, I'm not stopping you from doing that. But sometimes solving it for y equals mx plus b can create other problems that you don't need to get into. I have 2 points, and those 2 points make a line, and I'm ready to draw that line. How about you? Now, there's a lot going on here, but if you can just for a moment focus on the diagonal line, you could argue that you could use a test point. I could use a test point of 0, 0 because it is not on the diagonal line. And very quickly, I could plug in 0 for both x and y. And of course, when you plug 0 in for both x and y, you probably don't even have to write it, but I want to make sure you understand that we're looking at the statement 0 is less than 12. How does that statement sit with you guys? You should say yes, 0 is less than 12. So it's true, which basically means I'm going to shade on the test point side. So I'm shading on this side of the diagonal line. And of course, what we're really looking for is the overall shaded, common shaded region. Did you already notice that it was like this little pizza slice right here? I don't know if you're hungry already, but it looks pretty good. Okay. Now remember, the shaded region is actually the answer to the problem. So we've answered the problem, yay. But the corner points end up being some of the most important points. Now remember, the corner points have to be the intersection of lines. Most people, without any disagreement, will say that's a corner point. It's definitely the intersection of lines, and I agree with you. By the way, we have to figure out what it is. This is also a corner point because it's actually the intersection of the first boundary line, which was the y-axis, and the last boundary line. Oh, I already know what that one is, so I can get that in the list right away. And this one down here, that's kind of doubled as a test point, but double zero is the intersection of the first two. It's the intersection of the parabola and the y-axis. So double zero makes the list. Here's what you want to understand. Not every point is a corner point, like namely 3, 0 was just a helpful point, but it's not a corner point. It doesn't touch the shaded region. Let's go after this point right here. Same thing, warning, warning. This is going to be a little algebraic. Okay, it's going to be like a little fancy. How do I find the intersection of two lines? How do I find the intersection, or should I say, how do I solve this system? Okay, now that system's got an x squared in it, I know, but it also says that y equals x squared. Try it with me. It's the substitution method. I can substitute x squared in for y to find that corner point. It's going to be 4x, but now it's going to be x squared. Little substitution here. Now remember, I can just kind of pretend that it's equal to 12. I can just like ignore the less than sign because right now I'm trying to work with just a single point. Okay, so the equal sign looks good. Now I don't know what you think about this equation. It's not one that we've spent a lot of time with this year. You should have spent some time with it last year, and we're going to spend some more time with it in a few weeks, but it's basically a quadratic. A quadratic, that's fancy talk, but it's an equation that needs to equal 0. Now, I also rearranged it a little bit, didn't I? I put the x squared first, I put the 4x in the middle, but that should be something that you guys feel like you've seen since your algebra days, especially when it's equal to 0. It should kind of like be feeling like it needs factored. You want to feel the factor. Okay, this is how you go about solving an equation that's a quadratic. If you can factor it, you need numbers that multiply to be negative 12 and add to be 4. Multiply to be negative 12 and add to be 4 would be minus, or check that, plus 6 and minus 2. Of course, the answers are going to be, in this case, the opposite of these numbers, negative 6 and positive 2. Now remember what we're doing. We're trying to find an intersection point. Okay, that means we're trying to find the value of this point. It'd be kind of silly for you to tell me that it was like negative 6 comma 2 or 2 comma negative 6. Careful, those are x values. Now if you look at these x values, you should feel like that one of them is the one that makes sense. In other words, the one that's positive. So I'm going to take the number 2 and I'm going to use that as my x value. How do I find the y value? How do you find the y value? If you know that x equals 2, you know that y equals 2 squared. You know that y equals 4. So we're actually finishing the substitution method. We're just plugging it back in. And that's our third corner point. As I've said a few times, those points end up being the most important points. So trust me, find them, and we'll tell you why next week. By the way, x equals negative 6, it wasn't like wrong. It doesn't like sort of just not make sense. It's just that it's somewhere else, right there. That's the other place where the parabola intersects that line. Okay, it's just not part of our diagram or part of our shaded region. Okay, so we can kind of cross it out or just not worry about it. Systems of inequalities, okay? What I want you to do as a mini assignment, it simply means that it is something that I want you to try to get right, something that'll be graded and you'll turn in, and maybe you'll turn it in before you leave, but it's those 3 problems on the back, okay? I would assume that right now is a good time to See if you can work those out. You're in good company. You can talk about them if you want. Okay, so it's the 3 problems on the back. Now, you will hand this in, but I will give it back to you so you won't lose your notes.